Alright, for this video we're continuing with part 2 of section 9.3, geometric sequences. Today we're going to be talking about the sum of geometric sequences. So before we get to that, let's take a look at a quick example. So back in section 9.1 we would have looked at something similar to the sum as n goes from 2 to 4 of n squared over 2n. And the only way that we knew how to solve this was to substitute in the numbers 2, 3, and 4 into our expression and then to add it up. So starting with 2, we'd have 2 squared over 2 times 2, and then we'll substitute in 3, so 3 squared over 2 times 3, and then substitute 4, so we have 4 squared over 2 times 4, and then however you wanted to calculate this, hopefully I've got the right answer here. The sum of these three terms would be 4.5. So it's a sequence, we just don't give it a special name, and we had to add up the terms manually, so figure out each one. Now when we got to section 9.2, arithmetic sequences, if our expression was arithmetic, then we had a formula that we could use. So let's say we had the sum as n goes from 10 to 85. Obviously there's a lot of terms, you don't want to add those up by hand. We've got 3n minus 2. Now if you don't recognize this as being arithmetic, what you may want to do is plug in the first few numbers, so plug in 10, plug in 11, plug in 12, and make sure that you have a common difference. So since this is arithmetic, we know we have a formula. It's going to be n over 2 times a sub 1 plus a sub n, and that's going to be our sum. So we need to figure out how many terms. So the number of terms, remember we have to subtract 85 and 10, but then we have to add 1 back. And if you have a question about that, make sure you ask me in class. So we've got 76 terms. We need the first term. So the first term we get by plugging 10 into our expression. So it's going to be 3 times 10 minus 2. That gives us 28. And we also need the last term, the term that we get when we plug in 85. Since there's 76 terms, that's going to be the 76th term. So that's 3 times 85 minus 2. So that's going to give us 253. So now with these three values, I'm going to substitute those into my formula. So I'm going to have 76 divided by 2 times the quantity 28 plus 253. Plug that all into your calculator and hopefully you get 10,678. So sequence in general, no formula, figure it out by hand. Arithmetic sequence, we have this formula n over 2 times a sub 1 plus a sub n. Now moving on to geometric sequences, if you recognize that the sequence is geometric or they tell you that it's geometric, we're going to have actually two different formulas for this. So sums of geometric sequences. So for a geometric sequence, we can have a finite sum, or we could have an infinite sum. Formulas are a little bit different. So for a finite sum, the sum of your n terms is going to be g sub 1, so that's our first term, times the quantity 1 minus r raised to the n, remember r is our common ratio, over 1 minus r. So this is if it's finite. So we're going to add up the first 20 terms of some geometric sequence. We can, however, do the sum of an infinite geometric sequence. And our formula here, it's a little bit easier. The sum is going to be g sub 1, so simply take the first term and you divide it by 1 minus the common ratio. Alright, so just so we're clear on what all these things here are standing for, we've got r as the common ratio, and we've got g sub 1 is the first term, and we've got n is the number of terms, and s is standing for the sum, equals the sum. Okay, and this is for both of these. Alright, so there's our formulas. Let's take a look at a couple of examples. Alright, so first example, let's say we have the sum as n goes from 0 to 12 of 4 times 0.3 raised to the n. So the first thing that you need to recognize is this is a geometric sequence, and again, if you're not sure, start plugging in a few values. Plug in 0, plug in 1, plug in 2, maybe plug in 3, and look at your sequence of numbers and make sure that it's going up by the same amount. If you do that, you'll notice that each term is multiplied by 0.3 to get to the next term. So we want to find the sum of these terms. So we know that the sum of these n terms is going to be g sub 1 times 1 minus r to the n over 1 minus r. Okay, and we know that our common ratio is going to be 0.3, and again, if you're not sure how to find this out, just figure out a couple consecutive terms, divide them, and you'll get the common ratio. And we're going to need the first term, so g sub 1 we get by plugging in the first value of n, so that's 0. So that's 4 times 0.3 raised to the 0, so that's just going to be 4 times 1, which is 4. And we need the number of terms, so the number of terms, same as we did for arithmetic, we're going to do 12 minus 0, add 1 back, so we get 13 terms. So once we have these three pieces of information, we're going to substitute into our formula. So the sum of these 13 terms is going to be g sub 1, which is 4, times 1 minus 0.3 raised to the 13th over 1 minus 0.3. Now if you're plugging this into your calculator, you can do it in one step, although many students like to do it one step at a time, so they'll do the numerator, divide by the denominator, and then multiply by 4. But if you want to plug it into your calculator, you're going to do 4 times, and then we need parentheses again for the numerator, so 1 minus 0.3 caret 13, close your parentheses, divided by, and then another set of parentheses for the denominator, 1 minus 0.3, close and close. So plug that into your calculator and you should get 5 point, and I'm going to carry this out a bunch of decimal places even though we normally won't, 7, 1, 4, 2, 8, 4, 8, 0, 3. So again, a little excessive with the number of decimal places, but you'll see the point after we do the next example. Okay, example number 2 here. Again, write down any questions that you have in your notes and make sure you ask in class. So let's look at a very similar problem. Let's look at the sum as n goes from 0 to infinity. So now we're going to add up every single number in the sequence. So that's kind of interesting that we're going to add up an infinite number of terms of the sequence, and we're actually going to get a number answer. So 4 times 0.3 raised to the n. So if you notice, we have the same expression that we had in the first example, except that now instead of the first 13 terms from 0 to 12, I'm doing every single term starting with 0. Okay, so our formula for this one, S, is equal to g sub 1 over 1 minus r. So we need the first term again. So the first term, we're going to plug 0 in because that's where we start. So we have 4 times 0.3 raised to the 0, which is 4 times 1 again, which still is 4. And we need the common ratio. Common ratio is still going to be 0.3. And then we just substitute it into our formula. So S is going to be 4 divided by 1 minus 0.3, which is 4 divided by 0.7, which is 5.714285714. So again, we won't normally go out this many decimal places, but I wanted you to take a look at the two different answers here. So this is what I get when I add up the first 13 terms going from 0 to 12. This is what I get when we add up every single term in the sequence. Okay, up to 9 decimal places. So you can see up to here it really is the same, so there's not much difference. So what I want you to think about is, why isn't there much difference when we add up the first 13 terms as opposed to when we add up every single term possible? Okay, so think about that. We'll talk about that in class. Let's take a look at one more example. That'll be the last example for this video. Again, after we get the problem written down, if you want to pause the video and see if you can figure it out on your own. So let's say we have the sum as n goes from 1 to 50 of 3 times 1.02 raised to the n minus 1. Right, so again, if you're not sure that this is geometric, plug in 1, plug in 2, plug in 3, divide a couple of terms to make sure that you get a common ratio. Alright, and you can see we have 1.02 raised to an exponent. This is going to be my common ratio, and that's the pattern that you can look for. So I know S is going to be g sub 1 times 1 minus r to the n over 1 minus r. So I need the first term, so g sub 1, I'm going to plug our first value, which is 1, so that's 3 times 1.02 raised to the 1 minus 1. So that's 3 times 1.02 raised to the 0. It's 3 times 1, which is 3. So a lot of times our first term will just be our coefficient over here. I need our common ratio, so that's going to be 1.02. And I need the number of terms. So that's going to be 50 minus 1, and then add 1 back. 50 minus 1 plus 1. So that's going to be 50 terms. S sub n. Alright, so the sum of these 50 terms is going to be the first term, which is 3, times 1 minus 1.02 raised to the 50th over 1 minus 1.02. Alright, feel free to pause as you plug that into your calculator. And going out a couple of decimal places, hopefully you get 253.74. Right, as usual, write down any questions. Make sure you ask in class, and we'll see you in the next video.